Alright, 8th graders, lesson 55, nets of different shapes such as prisms, cylinders, pyramids, and cones. So a net basically would be if you took a cereal box. So we'll draw that here. We'll take a three-dimensional cereal box here, and I gotta put a little guy's face here. We'll call it some Wheaties. Anyways, if you were to cut that box, then we would have here, if we shaded the top, then my top piece would look like that. And then if I shade the front right here, then that piece will be over here. So I guess I should color code that as I go along. That'll be that. Get red back up here. And this side over here, that will be right there as I fold that out. Now, what we can't see with this box here is that each of these sides, so this side has an opposite side over here, this top has a bottom, and the front has a back. So if I were to, just like I flipped this side out over here so it looks like this, I can do the same for this side over here. It's as though I folded that out there, and I'll make that a matching blue. My bottom, that would flip out down here, so I'll make the bottom here red as well. And then the back would flip out below that. Now, the problem with me doing it just this way is that's not always true. Our back could have opened up over to this side. So there's a lot of options. So we can try that with some different boxes just to see. But this is what we call a net, because we've taken this three-dimensional shape and we've broken it down into a two-dimensional shape. So this is 3D over here, and this is 2 dimensions. This has length. Over here we've got length and width and height. Over here we've just got all lengths and widths, no thickness anymore. And that's been flattened. At example 1, and here we see an object that looks like this. And if we put that together, what would that make? Well, if this got folded down here and this got folded up here, then we rolled this, we would have ourselves a cylinder. This would be the top, this would be the bottom, and then this would be the side. So the net there would be a cylinder. So in example 1, they give us a formula that relates to each part of the net. We know that the top and the bottom, we could find the area of a circle. Okay, so that would be, well, here for this would be pi r squared, radius squared times pi, and then we need 2 of those because there's a top over here and a bottom over here. Now, to figure out the area of this shape, you can say, oh, that's length times width. But the problem is we didn't measure that, but we can figure out the circumference. This edge should match this circumference because it goes that paper goes all around the edge. Okay? And so we know that the circumference, so we'll get that over here. We'll add that over here. The circumference is going to be the diameter times pi. Put that in parentheses here. Pi times diameter. And so that's just going to be the length of this side. And then we also will need the length of this side over here, so we call that the height. And that would tell us what our total area is. Now, you notice in the book, they put a R in here for D. That's the radius, so that's why they have a 2 out here, because they have to do 2 times the radius. For you, it might be easier to do the diameter and keep it simpler that way. So we could figure out the area here of example 1. Okay. Alright, example 2, sketch a net for the triangular prism. There we have our triangular prism. Again, if I just have the bottom that we can't see, and then the ends fold down like this. You have one side up here and the other side on the back side. Your net is going to look like that. Now to discover the area of this figure, we can find the area of the triangle, the area of the triangle, the area of each rectangle, and discover the area there. Alright, in example 3 here, sketch the front, top, and right side views of this figure. And they want them to kind of be a representative. So the front looks like this. It's a little bit longer than it's wide. The side is skinny and tall because it's 3 centimeters tall and 2 centimeters wide. So the side looks like that. And then the top is only 2 centimeters wide, but 4 long. So it's a little skinnier than what we have up here. So this would be the front. This would be the top, and this would be the side. And then it says draw a net. So front, side, side, top, bottom, and then the other side. So front, top, bottom, the back side. This would be a side, and this would be a side. So that would be how we would do example 3. You see there an activity, and it basically lays things out for you. But if you wanted to build a cone, obviously the base of the cone would look like that. And when we if we make a cone, comes up 2 points, got a very wide angle, and then a rounded base like that, so that when we curled it all up, it would be pointy up at the top over here, and the bottom would be like a skirt that would go around that circle. So if we try to, it's not going to let me move those there. If we actually to have this actual net, then we would have the circle touching. I didn't do a good job of that there, but it'd be touching that. But you can do that activity when you're done with your assignment, if you have time there, to learn how to construct a cone, just so that you're familiar with seeing this in the future. They'll say, what net does this form? And hopefully you'll recognize, oh yeah, that's a pyramid.